Okie dokie. I think
You're doing it wrong.
I think every one of our videos starts off with me going, okie dokie.
You know, I've only went back and watched one of them, so.
So here we go. All righty.
Okay.
So question 2.
I picked the third one.
Me too.
Me too.
All right. I like that consensus.
We might be able to get through this quickly.
Yeah, don't count on it.
Yeah.
Question 3.
Taylor knows where blank paper is.
I picked the 4th one.
I picked the first.
I picked the second, so that means talk this out, huh?
Well,
I remember that this was kind of like, I remember them talking about observational is just you're watching things happen, you don't do anything. They're at least rolling the dice, right? I mean, an experiment. I mean, sorry, an experiment.
An experiment means that you've added something into it.
Oh, that's right. It is definitely not an observational study. I was going backwards.
See, I actually think it's observational because all they're doing is observing the cereal and the price of the cereal.
But they did control which sampling method. They rolled the dice, right?
So, but they didn't have control over the price of the cereals.
Yeah, I think what we did was just an observational study, not an experiment. You know, with the NBA stuff. So that's why I think.
And observationally, you basically do nothing. Like.
Well, what are they doing though? They're just observing because but what are they doing to control the outcome? Like an experiment.
Well, let's see. They went to Albertsons and they rolled a die to decide which box they were going to start from. So say they rolled the dice and it was the third box. So they count over the third box. And then they recorded every 6 cereal after that. And that is actually not a stratified, but I mean, that's an actual thing. One of our kinds of, and so that's an experiment rather than an observational study, isn't it?
Well, here's the chapter 1 summary.
Okay.
The second bullet, it says, in a designed experiment, researchers control the conditions of the study. In an observational study, researchers don't control the conditions, but only observe what happens.
But isn't it controlled once they rolled the dice and decide every 6 cereal?
Well,
that's a control, isn't it?
I think that's just a method of choosing a sample.
But once you have a method of choosing a sample, it's no longer an observational study, right? Like if they're just like, go pick 6 boxes and they didn't specify any kind of anything. I don't know. Dang.
Let's see.
At first I picked the first one, but I'm thinking that because even ours is an experiment, isn't it? With the MBA? With our thing is an experiment, not an observational study.
It's not an experiment because we're not adding anything. An experiment, you're like you have a controlled group and non-controlled.
That's right.
Like
that's right. Controlled and not controlled.
It means that you're controlling something. You know, you're making a difference. So you're going to give placebo to one and this to the other.
Right. Okay.
The Jonas Salk polio experiment was an experiment.
Right. And so that's why I'm back to number 1.
Okay, so yeah, I definitely think it's observational. So it would be 1 or 2. So let's see. Had no control of the cereals, had no control of the price of the individual cereal.
See, I think it's the second one because they have no control over the price of the cereals. They did have control over which cereals were selected because they made the choice. We'll do the first, third, and then one after
True.
that.
You're right.
So
Because
they did
that
control
is
over-
what they were controlling was which cereals. Every 6th one after whatever their dice came up with.
Right. It's not like somebody handed them 5 boxes of cereal and said, here, figure out
Yeah.
the prices of these 5.
Or I only want to look at the ones that are over $5 or something.
Right.
Okay, so number 2.
Okay, I'm good with number 2.
Wow.
Okay.
For the Math 221 project, one group of students studied the ages of students on the BYU campus. They collected data from a random sample. The sample mean was 21.2 and the sample standard deviation was 2.61. An excerpt of the data is given below. Okay. The group notices an error in their data. The age of one of the males was entered incorrectly. He's actually 21. When the error is corrected, what will happen to the sample median?
So right now you got 100.
The median will increase.
The median will increase.
8. 3.
I'm thinking he's going to decrease.
3. 14.
And
Well, because
Let me see if
right now it's a 12. The minute you change that to a 21, the median's going to be different, and it's going to be higher.
Well, but we don't know what the rest of the data is, though. We could have other people that,
If that's the only error,
right.
yeah.
But if there's 100 of them and we're only looking at 5 of 100,
Right.
I think it's not possible to determine without the full set of data.
Okay, well, let's go back. And there's 100. The sample mean is 21.2. The standard deviation is 2.61. We're just talking about the median, though. Out of 100,
Right, but the other 95 people could be all 18 years old.
right? Well, I still makes me wonder to go from 12 to 21, and even in 100 people, I would still think the median would increase.
And I guess my logic, that's not the right word, it's not logic. My thinking,
Yeah.
it could be totally illogical. If I thought of a box plot, which I put up on my screen, if this right here is the mean, no, I'm sorry, this X right here is the mean, that line would be the median,
Right.
and an age 12 would probably fall somewhere down here in the first quartile area. So if we move that age 12 up to age 21, we're plopping him somewhere higher in the box plot. And if this guy is higher on the box plot, well, that just pushes everybody down by one notch, by one person. That's why I'm thinking that the median will go down, not by a lot, but just by a hair.
75 plus.
Yeah, gotcha.
85.
That's my thought.
85. No, you get, look.
No, I agree with your thinking if we were only looking at these 5 numbers.
Okay.
There's 95 other points of data.
Yeah, you know what? You see the fourth one down? You see those dots? That's a term used in those 2 dots are like the 3 dots. You know, like an ellipsis when you're writing an English essay.
Yeah.
If you have an insanely long thought, it's one sentence, but you really only need, 5 words out of a sentence by the prophet. You might use ellipsis to remove the part where he talks about something totally unimportant. That's what these 2 dots are on this chart. It just means that the information is there. This real chart does have a full 100 people in it.
Right.
This is just an abbreviated chart for the sake of putting it on our screen.
Right. So if you've got 100 people and you're saying one of them was wrong and it's going to go from 12 to 21, is it going to make that much of a difference? Or we can't really tell because we don't see all the data to be able to see that.
Well, if the sample was 21.2.
The sample mean, right?
And its true age was 21.
Instead of 12. So like the standard deviation, the standard deviation is 2.61. So changing that 12 to a 21 is going to bring it more to the right a little bit as far as like the tails or whatever. That 12's not going to be there anymore.
Yeah.
Well, and again, let's think about this. They're not asking what the mean is. They're asking what the median is.
Right. And Joan, what was it that you had said? It's not possible to determine?
That's what I thought, but.
No threes?
Well, because we know that all right, so we know that the sample mean is 21.2.
Right.
That's with the 12 in there. So if we change that 12 to a 21, that's not really going to change the mean that much, because it just gives you an idea, because that 21 is right where the mean is, right?
Yeah.
So but we're talking about the median.
Right.
I think it could change the mean from 21.2 to possibly
12 right here.
21.7, 21.8, 21.9.
So what all right, so I'm okay with saying it's going to move one way or the other. I just don't have a choice if it's increasing or decreasing. So
Okay, then let's
I'm looking at your screen there.
yeah, okay, now this is our data, this is our NDA data.
Right.
And this is just to see where the mean is and where the median is. Ignore all these other numbers.
Right.
But you can see the first quartile line, the mean, the median, or second quartile, the third quartile. So in my head,
Like this?
So like what you were saying is where you have your first quartile or the number 3142, say that was like our lowest, one of our lowest numbers. So that 12 is no longer there. So you're saying our blue box moves all the way up. Therefore, it makes the median move down.
that makes sense.
I think that's what I'm saying.
And
That's-
so
that
so
makes
that means the median decreases.
Right.
If that's how the box plot works, right?
I think that's what I'm saying, or that's what I'm thinking.
And so that whole blue box moves up. The median still stays like, in the middle, but the whole box moves up. So that median comes down. Those numbers are all lowered.
That sounds well explained.
Okay. Visually, that makes sense to me to answer it. The median will decrease.
Right. When you look at it that way.
Right.
Sucks, you know?
Okay. All right.
All right. This is going to take us a while.
I need
Well,
to take
yeah, and you know what? If it's wrong, we'll come back. So we'll go with the median.
Yeah.
We'll threes for
Yeah,
now?
yeah.
Okay.
All right. The time to complete a standardized test, testing center is approximately normal with the mean of a standard deviation of 10. Using the 68, 95, 97 rule, approximately what percentage of students will complete the exam in under 50 minutes? Give your answer accurate to 1 decimal, please. So this is,
So 70's in the middle.
so 70, right. So if you do, Sister Lemon and her graphic all the time.
Yeah, exactly.
70 and the standard deviation.
And so you've got the 68, the 95, 97 going out.
90. So your 2 standard deviations out. So you're at like this. At the 68% rule then, aren't you?
Ooh,
Aren't you at?
I win, and I win 100 points extra.
Yeah, I think we're very close to 50%,
I think this is a
or very close to the number 50.
That's 100 points only. Like we win that here. Okay.
Because it's less than. All right, let me open it up. Bye.
Standard deviation of 10 minutes. So each one is 10. So 70,
Copy.
80, 90, 60, 50. So the 50 minutes is on the left side, encompassing the 99.7. Or no, hold on. The 95.
Look, if you're ever in a position, you can win here. Or
70
here.
is the middle.
That's
So
100 points
60.
extra. So, wait, what happened to
I'm
the
looking on
points?
the left.
You sure those were
60 is the 68. So 50 is the 95. 50 is at the 95, right?
Yes.
Yeah.
And it's what percentage of students will complete the exam in under 50 minutes?
24, 28, 30.
So if you're at 95,
Yeah, plus 25. I got the bonus. So I got 100.
If you're at 95, it means, I believe,
30.
that 95% of all the students will fall into this range, and then that left tail is the left tail and the right tail both total are 5%.
right.
So just the left tail only, I believe, is just half of 5% or 2.5.
9 plus 2 is 11.
Yeah, I used to have those formulas just like in my head that 99.7 was this number, 95 was this number, 68 was this number, and now I'm like brain fried.
Yeah, I'm learning that I can't remember stuff from the beginning of the semester either.
Well, if you go to the normal,
Probability app.
right, and you put in the 95 is 1.645,
Right.
and you shade then the left side, it
And
comes
which-
up to 0.05.
Right.
Yeah.
But do we use, and then there's that whole thing, do we use half of that? No,
No,
because I only have my left tail highlighted at negative 1.645,
right,
and then the area at the top is 0.05.
right.
But I think that there's a number. In other words, the 95%, of course, it's going to be 5% is left because that's 100%. But there's an actual number that goes with each of these. Do you remember that? Oh,
Oh,
do you know what I'm
Actually-
talking about?
yeah. You know what? I can't find it, but I think it's
Oh, it's this.
2.35%.
Do you remember this, guys?
In fact,
It
When I
was and so when you're one standard deviation away, it's like that 13 point. I'm going to move my paper clip out. Let me see if I'm gonna hold this up. Let's see.
What's the standard deviation, 10?
You remember that?
The standard deviation for the question?
Yeah.
Standard deviation is 10.
Yeah, 10.
And the mean is 70.
Yeah. And so we go 2 standard deviations away, basically. And so I remember like using this, we had to like add them up, add each of those quadrants up. Let's see, I gotta make
Yes,
sure that I,
yes.
and so the part, so you had to add up that 13.5 and so you would add each of those up depending on what you had shaded.
Yes. So actually, I think the answer is 2.35.
Well, don't we have to add 2.35 and 0.150?
Oh, yeah.
And I'm sorry, where are you getting those numbers?
It was in, I wish I had a bigger, it was right after exam 1 review, or maybe it was part of exam 1 review. I got to make sure that what I'm showing you, and then I can see it too. Okay. Let me get right in here. So if I'm looking here, here's my 70, right?
Yes.
And then here's my 60, and here's my 50. So
Yes.
I need everything in this space, which is 2.35, and everything in this space, which you can't see real well, you can see it better over here, I think, is 0.15. So I have to add that and that.
Which is 2.5.
And so 2.35 and 0.150,
It's
which is 2.5.
2.5.
Yes. And
No.
so, do you remember kind of doing
Oh,
that,
yeah,
guys?
Yes.
Yeah, 2.5.
And so, let's see. So what's the percentage of students who will complete the exam in under 15 minutes? And so I'm saying it's 2.5% of them.
Not liking you.
No, wait, where's my points?
I think so. I think it's 2.5.
And they're saying, and what's interesting is give your answer accurate to 1 decimal place,
Right. 10,
That would be
which would be that 2.5.
20.
Oh my gosh, I kind of found something. I used to know.
29.
I can't hardly believe it.
36.
Why the
Okay.
review is nice, huh?
Okay.
Okay.
The scores on the LSAT are approximately normal with the 1 standard deviation.
Yeah, it's kind of hard to cheat now.
Find the 35th percentile of the LSAT scores. Give your answer to 1 decimal. So it's the 35th percentile.
29.
Find the 35th percentile.
I can never.
Okay.
Don't we have to get the Z-score here and then put,
Percentile, okay.
In that left of the space.
Yes, I think we get a Z-score first, and then we'll use the Applin.
Are you that?
No, whooping his butt, laughing at him like.
so that's the
Use some water.
150.7 minus 157.
You don't have
Okay,
a-
let's see.
so it's,
150.7 minus 157 over
Divided by 10.2.
10.2. Okay, let's see here.
I have a negative 0.617 or 618.
50.7 minus 157 equals
So-
divided by 10.2. I have a negative 0.618.
Yep. At the Z-score?
Okay, so then we come in here and put in negative 0.618, okay? And then,
Go ahead, go ahead.
so I have a z-score.
I want
No, you didn't.
copy.
Find the 35th percentile.
I don't
Use the applet.
like you. Alright, no, we're starting over. We're starting over for 1,000.
Okay, guys.
Sorry. We're starting over.
35th percentile.
1,000.
Wait, you're not gonna start doing, we just had two, we just go to 1,000. So right now, I got 100, 2, 4,
Oh my gosh, I need to do it.
10, 16. I got 160.
Goodness.
Oh my gosh, I really am so brain dead. This is awful.
I know, I'm feeling it. Okay.
Yeah, that's kind of, don't feel bad at all. Are you in my phone already?
No. No.
All right.
To find a percentile when z is unknown. X minus. Is that the, is that the,
Alright, you go.
I thought it was on our formula thing, but it's not. There's a find a percentile when z is unknown.
Hmm.
To go back to,
You know, on that formula form, that Excel spreadsheet, the second one here, maybe we get a z-score off that first.
off of what?
Your
On that-
formulas and calculations.
Yeah. So I have that on my screen. Let's see if that works. So that if
Who does that? You always do this.
the mean is
I don't mean to. That happens to me too.
50.7,
You think I'm doing it on purpose?
the standard deviation is 10.2.
Yeah, I do.
The x would be
It was the 157, right?
Right.
There.
157.
Let me look.
So maybe the z-score is 142.25.
Z-scores aren't usually that big, are they?
No, you're right. That's way too big.
So the mean is 150.7.
1, 2, 4, 5.
Find the 35th percentile.
So there's no more ones, all the ones that we played. You know what I'm saying? So that you can figure out what I have and what I don't have.
Okay, come on.
I can't believe I can't remember where that is. Like, two summaries.
Let me go back to the scores on the LSAT are approximately normal. A mean of 150.7 and standard deviation of 10.2. Okay. Again, I wonder if it's the same thing that we just finished. 35th percentile.
Because I only have 2 left, we have a little one. Pretty much, I know what you have. So like,
Oh,
what?
150.7.
convert z-score for a number above. Need the percentile, use the standard normal table.
Can't call you the actual name, so I'll just call you somebody with it.
Okay, I've got it.
All right, what have you got?
Okay. So we'll go to our applet.
Okay, applet.
I'll bring it up on my screen. Just in case
Okay,
here. Okay.
all right.
But okay, we're gonna shade just the left tail that would
Right.
kind of represent the 35% side of life.
Right.
0.35% and
35.
our z-score that spits out is negative 0.385.
Right. And I did that, but then I was like,
Okay, and then we do the z-score formula, which is the z-score times 10.2 plus 150.7.
okay. So, applet, 35% at top,
So
and left tail shaded. I'm making notes. Z-score equals negative
How about
0.385.
you let me go first?
Okay, so then we're using, oh, which one are you using? You came in so close, I'm not sure.
Yeah, it's this one right here. This here is
Okay.
kind of a
X equals
restatement or
Z
formula that Sister Lemon taught us.
times plus the, okay. So then we did negative 0.385 times 10.2 plus 150.7. I'm actually going to use my calculator just so I go through the process and understand it.
Right.
Negative 0.385 times 10.2
I don't even remember what the question is. Find the percentile.
plus 150.7.
So then it's 146.77.
Yes, except rounded to one decimal place.
146.8.
146.8. Yeah. And I remember this formula. This is what Sister Lemon taught us. It wasn't in the book,
Oh.
but to
find a percentile when Z is unknown. And they didn't give us a Z. Okay. So we found the Z in the applet. They gave us a standard deviation and the mean. And so that's how we come up with the X.
I think.
Well, yeah, I guess, and I knew that, like I was going there, but I was coming up with the wrong z-score. So that's what it was. So you have to get to the applet and shade the area to the left of the percentile point.
Yeah.
Right.
Input the percentile to the top of the box to get the real z-score for this formula.
Right. And it says, and like what we were working with is to find a percentile when Z is unknown, that Z equals X, minus mu over standard deviation. And so then you just change that algebraic formula around and solve for X instead of Z.
Yeah. I think.
Yeah, no, I agree.
I think you're right. Now that,
By the way, every exam I do, I click a bullet point or I click an answer, and every time I go, I think.
So 6 is 146.8.
146.8. I'm going to be here forever. blah, 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 skin cancer, 60, 70-year-old American men. Suppose you were part of the research team and take a sample of men from this age group and calculate the mean number of skin cancer spots in the sample. Also, suppose that it is known that the distribution of the number of cancer spots is right skewed. Suppose the sample size of this study is 2. What would be the shape of, it's still going to be right skewed.
I believe that is correct.
Yes.
So you read that whole thing and it tells you it's right skewed, it's still going to be right skewed.
Yeah,
Yeah.
concur.
Yeah.
Okay. Tanker trucks are designed to carry huge quantities of gasoline from refineries to filling stations. A factory that manufactures the tank of trucks claims to manufacture tanks with a capacity of 8550. The actual capacity is normally distributed with 8544 and a standard deviation of 12. Okay. Suppose that a random sample of 20 tanks is selected and the sample mean capacity is found to be 80. What is the z-score corresponding to the sample mean? Round your answer to 3 decimals.
I think I lost you one. Because when you lost the game.
Okay, so how, what is,
So, but here, if they claim it's 8550 and the 20 tanks show that it's 8550.
15,
oh, did you already put this in here?
Yeah, I
No.
think this is it.
Okay. Well,
Okay.
5, 10, 15, 20, 25. $30.
so
And then in my paper notes, I just have the formula. I don't
what
like
is
to
the
say it,
z-score
Right.
corresponding
For
to
the
the
test.
sample mean?
but since this has taken us forever,
So what is the z-score? So you did that. All right. So the X bar is 8550
Right.
and the mean is 8550.
No, 8544, right?
yeah,
Right. Wait. Oh, right. It's 8550 is what they claim that it is, but the mean is 8544.
Right.
The number is 20, and the standard deviation is
12, so it's 12 with over a square root of n. Or 20. 12 over a square root of 20.
2.236.
Yeah. Okay. What is the probability the sample mean capacity of 50 randomly selected tanks will be greater than 8540? Round your answer to 3 decimal places. So we go back.
Win.
We just replace n with 50. What are you doing there, Ed?
well, I guess I'm moving on to question 9, but we
Right,
still,
and that's what I'm looking at too. So do I just change n from 20 to 50, right?
yeah, 3.536.
So everything else remains the same. No, it wants to know if it's going to be greater than 8540.
That happens, it's your fault. You can't trade.
Okay,
So
go back to your little calculation screen for me.
for you,
Okay. So it wants to know what is the probability that the mean capacity for these 50 tanks will be greater than 8540. So my mean, it wants to know about my mean being greater than 8540 rather than 8544. Do you see it? You know what I mean?
Yeah, so
Did I-
maybe should we go back to a number of 20 trucks?
Yeah, so my n is 50 But it wants to know the probability that the mean capacity of those 50 will be greater than the 85/40.
Okay, so this is, again, this is where you have to look at the app, the normal probability app, right?
Right.
So you have is 85/44. So, and they want to know the probability of everything of 85/50. You put your, there's our Z.
It's going to be greater than 85/40 when you have n is 50. What is the probability?
So you want to unshade first little quadrant, because but I think you want the middle shaded too, because you want everything over 85/40 and the mean is 85/40.
Yeah.
10, 22.
Yeah.
12 more.
22,
12 is 34.
I think that's correct.
Okay, so we put in, okay,
45.
probability.
So we're saying the probability is 99%.
305.
Went to 3 decimal places.
0.987.
So that's what we say the probability is.
8.
Yeah. I think that
Okay,
is correct.
go back to your calculation one more
Do you
time.
want to go to that again?
Okay, so right now it's saying we change the n to 50, right? And then it's asking us to change the mean capacity to 85/40. And we want to know everything greater than 85/40. So if we change that to 85/40, doesn't it change our Z number?
Yeah,
Fine for that.
it makes it,
So is that the number we're supposed to put in?
Yeah, I don't know if we use this calculation for this.
That means you lose the game.
yeah, I think I'm with Joan. I think we don't need to change the mean or the number for this.
Okay.
We just go to the normal probability app and put in, because with the, we know that the mean in the middle is 85/44. Or it's 85/50.
Got it. Okay, I'm following you. Yes.
So we knew what the Z-score was from before,
Right.
but now we only want to see everything above that 85/40.
Right.
Which I think would make sense. If you think about it logically, it probably makes sense that 98% are going to have at least 85/44.
Yeah.
Okay.
That was well said, Joan. If you exclude all these numbers and just if you looked at tanker trucks and you were standing on an asphalt street, you would probably go, oh yeah, about 99%.
Right.
Are going to come up with that.
Yeah.
Okay. 0.987 it is.
Okay.
Which one of the following best describes the notion of the significance level of a hypothesis test? First one.
I'm sorry.
0.
Yes.
I think the first one is p-value.
Wait, you took another one?
No.
Okay, let's see.
These were.
Which one of the following best
You're
describes
right.
the significance level of
No, you
hypothesis
took
test?
another one.
I didn't take one.
Yes, you did.
The significance level of a hypothesis test. The probability of conducting HO, whether it's true or not. I don't think it's anything. I don't think it's the type 1 or type 2. I don't think that has anything to do with it. And I think you're right. The p-value, that's the
Yes.
definition of a p-value.
15, 20, 28.
I think I'm going to go with the bottom one.
Yeah, me too.
31, 4,
with the bottom one, right?
Yeah.
Yeah.
4,
Oh, I just realized I've not been saving my answers.
Oops.
Hold on.
Okay, you can just save them all now
Oh my
and it'll still
God.
save it all.
Yeah,
Yeah.
but I kind of like to see like where I'm at and if I, Okay. Let's see. We're almost to the 25% mark.
An hour, 40 minutes into
Oh
it.
my gosh. Okay.
Or Sister
height-
11. Maybe,
The
maybe,
height-
maybe
Yeah,
she
we're gonna have to
does-
apologize to Nikki for her having to watch this.
Oh, that's right.
The
Yeah.
heights of young adult females in the United States are said to have a population standard deviation.
See if she can post on the Providence Board News.
Are you guys still there?
Yes.
Sorry,
Oh, okay.
the heights of that have a 2.6 inches. A sample was taken of 85 young adult females at BYUI, and the mean was computed to be 65.4. Which of the following explanations describes the correct way to interpret the 95% confidence interval? That's okay. So it has nothing to do with any of the numbers.
Yeah.
So it's either the last one.
there's 40.
I think it's the last one. 95% confident that the true mean height of adult females in the United States is somewhere in our confidence interval.
I agree with the last one. I also think the third one.
No, because it says chance.
Oh, the word chance is in the third one?
No.
Oh, I'm sorry. Approximately 95% of all 95% confidence intervals that could be computed from the population of all adult females in the United States will contain the true mean height.
See, I wondered about the third one as well.
Well, because, right. Oh, it does say mark all that apply.
Oh.
So
Yeah.
it could be both.
Yeah. Process of elimination tells me it's either 3 or 5 or both 3 and 5.
Yeah, that's where I'm at too.
Well, I think if it says mark that all that apply, it'd be safe to say both of them.
Yeah. Or it wouldn't have given you that.
Right.
Okay, that's good. That's
Mark all that apply usually means at least more than one.
okay. That's kind of them.
Okay. 12. Marine biologists have been studying the effects of acidification of the oceans on weights of the male beluga whales. I don't know of any whale that's been studied more in statistics classes than the beluga whale in the Arctic Ocean. One of the studies involves a random sample of 16 beluga whales. The researchers wanted to create a 95% confidence interval to estimate the true mean weight of male beluga whales. Their data follow a normal distribution. The population standard deviation of weights of male beluga whales is 125, and the researchers feel comfortable using this standard deviation for their confidence interval. Are the requirements for the use of a confidence interval met? The sample size, the first one, it's not large, it's only 16. The distribution of the sample means it's normal because the data is normal.
What? Central Q.
You're such a cute little baby.
Oh, yeah.
I'm kind of thinking it's the second one.
So,
One of the studies involved, so there was only 16 whales.
Yeah, I mean, it's a small sample, but if we took the 16 and we did a QQ plot with the 16, I mean, we could do it with 5. Well, that's awful small, but we could do it with 16. And if a QQ plot is basically on that line, then that is de facto normal.
Right. It's either the second one or the fourth one. The fourth one, though, I'm thinking it isn't that because you can't say the distribution of the sample means is not normal because the sample size is too small. I just don't think you can determine that given the information that we have.
Right. Okay. Right.
Okay, so the confidence interval requirement though needs to be greater than or equal to 10.
She did that on purpose. We got threes over there. You got like a bunch of threes. That's why.
You know what? I don't think that one applies to this question.
He wants to have
The
a bunch
requirements for the use of a confidence interval met. So if this is a one proportion test,
Finally. You don't have any threes?
I don't think this is a,
Well, you picked this up and looked at it.
this is a quantitative test.
Yeah.
What? Get out of here, trying to cheat.
Oh, anyway,
You don't know that?
I'm pretty sure I did.
so the 95% confidence with the estimate the true mean weight of the male.
Okay, I've got requirements for confidence intervals. A random sample has to happen. The sampling distribution of X bar is normal,
Mhm.
and you establish that in one of three ways. We are told the population is normal, or we check a QQ plot, or by the CLT if N is greater than 30. So it's only by one of those three.
And they told us it was normal.
Yeah, so they told it was normal and it was a random sample. And
Yeah, I can go on that 3.
so that's the only thing that we have to meet for confidence interval.
Okay, that sounds like,
So it's the second one, right?
yeah. Okay,
I can't go.
good nose reading.
Yes. The distribution.
This boy.
All right.
Especially with the- yeah,
Go ahead. An investor with a stock portfolio worth $700,000 sued his broker and brokerage firm because he felt the lack of a diversification in his portfolio led to poor performance for many years. In an effort to avoid close public scrutiny, the firm agreed to settle the conflict by an arbitration. The arbitration panel compared a sample of 39 months of the investor's returns with the average of the Standard & Poor's 500 stock index for the same period in order to determine whether there was substantial decrease. The data recorded in rates of return. The S&P has a known population mean return of 0.95. Suppose that you're a member of the arbitration panel. Conduct a hypothesis test to determine if the investor's portfolio performs significantly worse than the performance of the S&P 500. Use level of significance of 0.05. What is the p-value for the test? Give your answer accurate to 3 decimal places. So this is QIP and these rates of return.
2.
Oh, you got 2 in here. You got the 5 and 6.
And it's a single, right? Because we only have the, well, we have to open it.
Go.
Yeah, it's an unmuted
Go.
I win.
quantitative inference procedure Excel.
I win.
No, I won.
Okay.
And I win 100 points.
Okay. So
All right.
One sample
Yeah,
t-test.
one sample t-test,
Nah.
cut and paste. All right.
You only get 12.
Let me make sure I have, okay. Confidence interval is 0.95. Null hypothesis.
You can't let me win.
Do we have a null hypothesis and we don't have to worry about it?
All right.
So they want to know if it's worse. So that's less than.
Right. Do we have to have something in the null hypothesis though?
I think so. In the last sentence of paragraph 1, it says the S&P has a known population return of 0.95. So the null is this investment firm was equal to the S&P 500, which would be 0.95.
And so the confidence level is 0.95 and the null hypothesis is 0.95?
It looks weird having both of those
Yeah,
on the
that's
same.
why I was just like, that's why I was questioning myself.
Yeah, it looks funny.
Okay, so I've got a p-value of 0.019.
Okay.
Is that what you guys have?
Yep.
Yepers.
0.019.
Oh man, we did
Okay.
all that for just one question.
0.019.
Oh my goodness. We only did that for one question. Great. How many of these are they going to give on the test? We only have to use for one question.
Oh gosh.
A financial economist is studying married couples in which both spouses work. Dependent. He wants to compare the mean income earned by husbands with the mean income earned by their wives. Should he use independent sampling or dependent? Dependent for sure.
Right.
So the second one says dependent sampling needs to select couples for his sample. So whether a particular wife is included depends on whether her husband is included. Yes.
It's the second one.
It's the
I
second one.
agree. Yepers.
Evil.
Yeah.
Evil.
Okay. All right, the next one. Use the following information to answer the next two questions. This is going to be with direct flight costs. So have that up and ready, guys. Let's see. I'm just going to, mine takes a while to load, so I'm going to load it. Pressures of supply and demand act directly on the prices of airline tickets. Oh, now everything's popping up as I'm trying to read. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. Allie, a BYU Idaho student, wanted to determine if there's a difference in the price of tickets listed 90 days before a flight compared to 14 days before the same flight. For her study, she compared the prices of one-way flights from London's Heathrow Airport to various destinations in Europe. Using Travelocity, she recorded the lowest published fares for 90 nonstop midweek flights for 90 days, and then found the lowest published price for the same destination again 14 days in advance. The prices are given in this file. Notice that for some destinations, flights were not available. So this is a paired test for sure, right?
Yep.
Okay.
So you have the 90 days in variable 1.
So paired test, the post, and I have post and pre. So I have 14 days in column A and 90 days in column B.
That sounds correct.
Okay.
I did it the other way.
Because
Yeah, 'cause I have to read it.
yeah.
Yeah, it's kind of confusing because technically they're both before the flight itself.
Right. But 90 days comes before 14 days. So you had to get the 90 days as the before or the pre compared to 14 days is the post or the after. Which one comes first goes in B.
And that was my thing.
Okay. So
Okay. So I've got that, but I want to make sure I've got everything else in here.
so I just have to move my numbers then. Hold on.
So it's really just a not equal situation.
Yes.
Not equal. Null hypothesis is 0.
So, so we
Yes.
did 14 days in column A.
14 days in column A.
Yes.
And that's your post, right?
Yes.
I'm going to write that. 'Cause I know you're so good about doing that.
14, 16.
I just actually leave it in my QIP. I put,
Yeah, well, I downloaded the whole thing.
oh, that's right. You did
Messed up.
download a new one. Yeah.
I got so messed up the other day, and that's my concern that it'll do that during the
Right.
test.
So I have a p-value of 0.096.
Right.
Based on the results of the test, can you say that there is a difference in the cost of airline tickets purchased 90 days in advance compared with 14 days in advance? Use the level of significance of 0.05.
Like, so far from you.
So the p-value is higher.
High, yeah. Keep the guy.
300?
If you win now, if you beat me this time, you get 150 points
So she was saying, let's see.
first try.
She just want to know if there is a difference.
Not now, but the second game. you get 150.
Right, so we're just saying, is there a level? So yes, there is. It's greater than,
75.
so yeah, there is a difference because
14.
value was greater than the level of significance.
Yes.
4 chances to make some bonus points. It's only for you.
I tripled already.
Based on the results of the test, can you say there is a difference in the cost? Yes. Go back here.
Give me bonus.
Ed, is that what you think for 16?
Yeah, I don't think so. I don't know. Okay.
Hold on here.
Strictly on the,
If I look at the N, the post is 88, the pre is 88, the differences are 87. You know, when I look at the box where it says the mean and the standard deviation and the standard error of the mean,
right,
Mhm.
and it gives you the null hypothesis is HO is, you know, the equal to 0. And our p-value is 0.095 and it's higher. So if it's high, we keep the guy, meaning we keep the null. So it's not saying that it's that much different, that it's different. My N for my post and my pre is 88.
yeah, that doesn't look like much of a difference, does it?
Look, I won.
Or the difference is so small.
Dang it.
That it's insignificant.
I get 20.
Because I go back to, it might just looking at my p-value. If it's high, I keep the guy, right?
Yep.
Right, so you're keeping the HO.
And so when I read it, based on the results of the test, can you say there's a difference in the cost of airline tickets? And I'm saying,
I'm trying to keep you.
because of that, I'm not rejecting that hypothesis. There is no difference.
It'd be nice if I was like,
So we're saying then no, because the p-value is greater than the level of significance.
Yes, that is correct. The
That's
first one.
I think it's the first one. But it's, you know, but you're right, Raylene, that's in your brain, that's counterintuitive. Everybody knows that the fares change are different 90 days out versus 14 days out. But I guess in a mathematical sense, it's not.
Well, and in this particular situation with Heathrow Airport and going just to Europe, maybe those prices, both 90 and 14, stay about the same in that same area. If she was doing it more in all the different places in the United States, or do you know what I mean? It was a very small thing, Heathrow to just other places in Europe. So when you think of like flights between Miami and Tampa compared to flights between Tampa and Salt Lake City, you know, those are longer flights. What I'm saying is it was one airport, and just in Europe, which whether you go north, south, east, and west, it's, you know, 1,000 miles every direction. Do you know what I mean?
Yeah.
So that might be why there isn't as much of a change as if you were flying from coast to coast in the US and
Yeah.
from coast to Midwest or something.
Okay. Okay, then we'll go with the first one, no, for now. I'm on board with you guys.
All right. We're almost halfway. All right, 17. A real estate company wants to evaluate 2 of their home appraisers for consistency in preparation for their annual state certification. It's important that different appraisers be able to give similar estimates for homes and other properties. We've had kind of a similar one like this.
Yes.
The company selects a random sample of 10 homes in different neighborhoods around the city and independently asks each appraiser for an estimate of the home value. After they receive the estimates for each home, the company subtracts the value given by the first appraiser from the value given by the second appraiser. So it's 2 appraisers is all. They create a QQ plot of the differences and see that the points in the plot roughly form a straight line. Are the requirements for using the desired confidence interval satisfied? Wow.
Well, it's yes, because the data have been determined to be normal on the QQ plot.
Yep.
Let's see. They create a QQ plot of the difference to see the points in the plot roughly form a straight line, which is normal. So the third one.
I believe that is correct.
Okay.
You guys are on it. Very good.
All right. Now suppose the company of the previous question wants to use hypothesis test to determine whether the estimates given by the 2 appraisers are different. Which of the following would be the most appropriate? So it's got to be the first one has to be equal. The second one has to be not equal.
Right.
So that's only the first one or the third one.
Right. So
I think it's the first one because you're saying person number 1 against person number 2. And then the alternative is person number 1 and person number 2.
right. Because the third one would be the data, and that's not really what they're
Yeah.
looking at the data, they're looking at the people, right?
Aren't they looking at the mean? Okay, it's definitely, it's dependent. We determined that it's dependent, right?
Right.
And we determined that it's quantitative.
Yeah, but on the first one, we say appraiser number 1 is equal in his estimates as appraiser number 2, or our alternative is they don't appraise the same. Person number 1 does not praise the same as person number 2. That's our alternative. Because it's about whether they appraise the same or not whether the data because each house can be a different amount. You know, one house is 250,000, another's 120,000. You know, it's not about it's not about the data, just if they were appraising them the same or different.
Yeah. You know, I'm looking at the chart that Mr. Lemon emailed us, and the 2 group dependent matched pairs t-test in this blue cell has the mean of the differences, not the mean of the ones. Not the mean of.
Okay, right. I'm looking here. Groups are dependent, matched pairs or groups are independent. Because they couldn't really do it if they didn't have appraiser 1 and appraiser 2.
Yeah, gosh, in my brain, I'm thinking this is about differences, though. In fact, in the question.
Oh, okay. So, and that's just what I just did. So the company selects a random sample of 10 homes in different neighborhoods around the city and independently asks each appraiser for an estimate of the home value. So they were each doing, of those 10 homes, each one gave an independent appraiser the estimate for that home value.
It doesn't matter.
Yeah, like, why are you getting a little far?
So I think since it says are different, is that when you go with the D then? Difference?
Yeah, well, and that these are dependent because they're using the exact the same houses for the first appraiser and the same houses for the second. The houses are dependent.
So all these points are
18,
mine.
19.
Yeah, because in the purple section, you read that the true mean of the differences, which is paired data. And then in the other one, it's the difference between the 2 means using independent samples.
Yeah, and these were not independent samples, they were dependent.
32.
This was the same house.
Right. Okay.
I'm going with the third one
The
down.
third one, based
me
on
too.
that. Yep. Based on that. That's right.
And when we're wrong, I will not only apologize to you, I will apologize.
Okay. We're all stab in the dark, you know?
That is exactly, it's all about process of elimination for me. And it's,
Okay, suppose you create a 95% confidence interval for a mean, and you get negative 2.346, 8.775. You've been told to report this by saying, we are 95% confident that the true mean is between negative 2.346 and 8.775. Exactly what does that mean?
96 points, look at that. It's almost, it's like there.
I think it's the second one down based on what Raylene taught us either last week or the week before, or maybe when we were discussing our project. We were talking about the interpretation of the statement.
We can't use the first one because it says chance.
Yes,
Automatically gone.
And the third one is gone.
Yes.
gone.
Your turn.
So number 2 or number 4, I agree with that.
And you almost got up.
Suppose you create a 95% confidence interval for the mean. Okay, we are 95% confident that the true mean is between 2.346 and 8.775.
You would have had
95% of all 95% confidence in between the two, or 95% of the sample mean. Now, it's not 95% of the sample means are between 2.34. It's the true mean between.
95% of all the 95% confidence intervals that we can grab actually contain the true mean.
That sounds,
Yeah, I don't think it's the fourth one. I don't think it's 95% of the sample means are between that, because I don't think that's what it is.
Yeah. And we never say a sentence like that either.
Right.
So the second one.
okay, I'm with you, ladies.
All right. If P equals 4/5, what is the smallest value of N that satisfies the requirements for a normally distributed P hat?
Okay,
6,
this I think, Joan, is that one where you have the greater than or equal to 10. Not sure. Let me see if I can find a note on this.
What divided by 5 is 0.3.
Isn't it your one on your 4 of 4 formulas, road 127?
Ooh, maybe.
See what you're doing? See what you're doing?
Which row did you say?
127?
Holy cow, that's way down there.
Or maybe mine's wrong. Let's see.
Okay, no, that's it. I think I added something
It's
later.
where it has a P hat and an N. P, confidence interval, Sister Lemon.
Yeah. Okay.
Right.
So
I'm not seeing it on your screen though.
Question is 4/5. If P is 4/5, what's the smallest value of N that satisfies the requirement for a normally distributed P hat? But we don't know what the P hat is.
the P hat and the P
Are
are
the same.
they're
Right.
said to be the same. So if Ralena's right about this formula, we put actually this is what I did when I did this did the quiz earlier. 80% decimal of P, and then
P,
since it's
what is the smallest value of N?
greater than 50, I think we use this one here, this formula, also known as this formula.
Right.
outside.
So I think we get 50.
Again, the question is, if P equals 0.8, basically. What is the smallest value of n that satisfies the requirements for a normally distributed p-hat? What's the smallest value of n?
So aren't we down, shouldn't we be down like we're 145?
We don't have this one.
You know what? I think I've made changes to my formulas and calculator sheet since I sent it out to you. I don't remember what.
You need to send us a new one.
Yeah.
Well, and but if you're down at 145, it's the minimum sample size for proportion. So it's a decimal of p, and if you put in point.
Are you looking at his on his screen, Joan?
Yeah. The one on my screen is I think that's the correct one.
Minimums, because we're working with that minimum sample size.
Right, that's it's 145 on mine now. Yeah.
Okay, yeah, his is row 132 and 133.
I know what I did. I added some linear regression stuff to this. That's why it's on.
Oh, okay.
That's
Yeah,
why.
so I definitely would love a copy of this.
Okay, I'm going to write a note to myself, but remind me also.
Okay. All right, so
Did you contact Megan?
we're gonna say 13.
No, I think it's the since we're dealing with an 80% figure.
Yes.
The 4 out of 5 is the same as.
Oh,
8
if
out of
P is greater than 0.5, so it's 0.8, so we use the bottom one, so it's 50. Okay, I'm following you now.
Yeah, I believe that's correct.
Okay. 50. Okay. Your little brother has a career batting average of 0.233. You want to determine the probability that he will have a batting average of over 0.250 next season when he will be up to bat 40 times. Are the conditions met so that the sample proportion p-hat will be approximately normal?
None of my pens are working today. I heard something spilled on my paper and it's not. Okay, sorry. 21.
That's prevent. Oh.
I think it's the first one. The other three kind of just don't make sense to me.
Number 3 definitely doesn't make sense to me, but I was trying to go through 2 and 4 to see if they made any sense to me.
707, 600. Not bad.
Thanks for that little catch me up. All right, your turn to
She
shuffle.
won 3 times in a row.
Your turn to.
So that means you could win, like you could actually, what if you get a copy too?
I'm waiting for that.
So, 40 times 0.250 is 10.
That's why you're so freaking high.
I'm about to
You
get
on like cloud 9.
right now. I'm about to-
Way up high in the sky.
Watch me kill.
Yeah, it's only one.
Yeah, the bottom one doesn't make sense at all because they're timesing it by their career batting average, which doesn't have anything to do with what you're trying to
All right.
do a probability of. So the bottom 2 are definitely out.
All right. So what's the
Well, the second one actually not. The second one is
10 is greater than or equal to 10.
Yeah, so it's okay. It's either 1 or 2.
But it's asking, are the conditions met so that the sample proportion will be approximately normal? 10 greater than or equal to 10, how does that help us see if they're approximately normal or not?
Well, I'm looking at the chart on my screen that Sister Lemon sent us.
Okay.
And the yellow, it actually does have the N1 times P hat 1 is greater to or less than 10, et cetera, et cetera, et cetera.
Right.
So maybe it is the second one. 40.
What happened last time?
The P hat is 40 because it's,
But I would have to do 1 minus 40, right? What? They've got 40 times 0.250, so I'd have to do,
One Mississippi, two
No,
Mississippi.
that's mine right there. Boom, you can't go there. Bam, go over here. I'm gonna put it right there.
One
Oh, this up.
Mississippi,
Guess what?
two
Guess what?
Mississippi, three Mississippi, four Mass.
this second equation isn't
You
making
know.
sense to me.
Oh,
Right,
Yeah.
because it's not just the one
No,
has to be
stop.
greater
No,
than
stop
or equal to
counting.
10.
Stop
The other
counting.
one has to be greater than or equal to 10 too.
Right.
Stop.
Did
Stop.
1 minus 40.
Oh, sorry, you forfeited the
You
game.
you cheated. You
Oh,
mad
that's a
'cause
good
you're not
point.
gonna win. You mad 'cause you're not gonna win.
Yeah, I'm with the first one.
okay. It's a process of elimination. I agree.
Yeah,
You're cheating, man.
that's what multiple
You're
guess is
cheating.
all about.
You're cheating right now.
Okay,
They say,
yeah, a geneticist takes a simple random sample of 140 sex cells from the testes of a dog to determine the proportion which contain the chromosomes for the development into a male. Assume the unknown true proportion of dog gamete, I don't know what that is, that contain the male chromosome is 46%. The geneticist conducts her survey and calculates p hat equals 0.512. Which of the following is the most correct interpretation of this statistic? There is a 51.2% chance the randomized count cell will have a male chromosome.
You got a 401?
okay, so
Okay, the second one is totally out.
the unknown is true proportion dog gametes that contain the microgram 46. The genetic p hat equals 0.512. Which of the following is the most correct interpretation of this step? 51.2. Nope.
Got no 5. Got a 5?
I did that.
I know we're not supposed to use the word chance.
Right.
The
Yeah,
first-
so the first one's out,
Yeah.
That's all right. That's all right.
and I think, all right, I have to read it again. So, which contain the chromosome for developing into a male. So it's the chromosome developing into a male. Assume true proportion of dog gametes that contain the male chromosome is 46. The geneticist conducts her survey and calculates that p hat is 0.512. Which of the following is the most correct interpretation?
This one you got the
1.2% of the eggs fertilized will produce female puppies. Well, that's not true. 50% of the gametes in the sample have, I would say it's the fourth one.
Yeah, I agree.
Because it's not saying that 51% of all the gametes in the dog tests, it's the sample.
Well, the one thing, you know, I might have been rash in saying the second one is wrong, only because it says testes of dog to determine the proportion which contain the chromosomes for development into a male. And so the true proportion of dog gametes, whatever, that contain the male chromosome is 46%, meaning the other percentage would turn into a female, right?
Yeah.
So the
Right.
geneticist conducts her survey and calculates 51.512, which of the following is the most correct interpretation. So my thing isn't just that it contains a male chromosome, or that that it will develop into a male. So does our sentence have to say something like that in there?
You go.
Peter,
You want me to shuffle again?
I want you to shuffle yours back in and take 7 new ones.
No, I gotta do the whole thing over.
No. No.
So 51% of all the gametes in the dog's testes have the male chromosome.
No, shuffle over.
No, it's okay.
No, shuffle over again.
But they're saying the true proportion of dog gametes that contain the male chromosome is 46%. So they're already stating that the true proportion is 46%. So then how do we get into this 51% unless we are talking about the females? That's what's mixing me up.
No, true proportion.
Yeah. If 51.2% of the gametes are one way, then 48.8 of the gametes would be the other way.
Or there's some unknown in there, I don't know. Because that's certainly, because the 0.51 and 4.6 don't equal 100%, of course.
True proportion of dog gametes that contain the male chromosome is 46%. So are we saying then that 51.2% will produce female puppies? Because we're saying it's the other side, but 51.2 and 46 do not add up to 100.
Well, and there's statistic and proportion, right? Aren't those the two different things? And we're looking for statistic.
Well, statistic and parameter.
Parameter, there we go.
Yeah, and the parameter is like the entire population.
Right. I just want to make sure. Okay. So
the true proportion of dog gametes that contain the male chromosome is 46%. Geneticist conducts her survey and calculates p-hat. So the population that sample population that she used had 51.2%.
Why are you always doing stuff like that?
yeah, the sample proportion.
If the word chance was not in the first one, I would go with that. If the word chance was not there.
Yeah, all right.
Okay, let's get one that's close but doesn't have chance then,
Who shuffled me?
which is the
It's the third one then.
You didn't even shuffle that good. No, that wasn't that good.
Because that's what they tested, the dog's testes.
Okay.
well, p-hat's about sample. So do we have to use the fourth one?
Well, that's what I said first.
Oh my gosh. So basically, if I word that again, the geneticist conducts her survey and calculates that the sample equals 0.512, right? The p-hat is the sample.
Right.
Which of the following is the most correct interpretation of this statistic? So don't we have to say that it's about the sample?
Then I'm going back with my first.
The fourth one.
Yep.
Okay, I'll go with that.
Okay, 23. Researchers published a study in which they considered the incidence among the elderly of various mental health conditions such as dementia, bipolar disorder, obsessive compulsive disorder, delirium, and Alzheimer's disease. Oh, it's great getting old. In the US, 45% of adults over 65 suffer from one or more of the conditions considered in the study. Calculate the probability that fewer than 320 out of the N equals 750 adults over 65 in the study suffer from one or more of the conditions under consideration. Give your answer accurate to 3 decimal places in decimal form. Holy moly.
These are the ones that I just don't understand.
Yeah.
I'm just never good at I'm not good at probabilities.
Yeah. No, they're very confusing.
45% of adults, let's just say, elderly adults suffer from one or more of them. So they could suffer. So 45% have 1, 2, 3, 4, at least one of them. Calculate the probability that fewer than 320 out of the 750, out of a number of 750 adults, suffer from one or more.
Okay.
So is that 320 divided by 750? I mean, it's heavenly.
Yeah, I think 320 divided by 750.
Is 4.26666.
Right, so it's 43%.
Give your answer after 3 decimal places, which is 0.427.
7.
Is that how you guys were doing it? Just simple, like the simplest calculation we've had to do so far?
Somehow I don't think that that's what it is, though. I think you have to take the 320 minus the 750.
Because it's fewer than 320.
Right.
So it's some number less than 0.42666.
So I think, I think this is where we need to get the z-score. Do the 320 minus the 750.
Ed, is this your screen you're showing?
Yeah. It's just kind of my worksheet.
Right, yeah, no, I put it all on there. Okay. All right, do we have our calculate z-score thing?
So our p hat is 0.427.
Put it on for the attacking Taiwan.
45%.
6 points. You're not that far behind.
How many points that?
So we have 109, 150 plus 19 is 26, 635.
So, like 67. There you go.
I have a feeling there's a formula, and I'm having difficulty.
I was looking for it too.
Yeah. Let's see.
Well, it's being done the same way like before when we were doing the tanker trucks, right?
No, I want that.
Yeah, maybe. Hmm.
Man, walking over there, we just naturally got to pick up, pick up another. Pick up another one. Pick up another one. You that, okay, go.
Pick up another one.
Hmm.
You gonna be mad when I leave the Scotch cool? You gonna be like, you're a cheater, you got to cheat.
Okay, maybe.
You're supposed to, if somebody has to, you got
We
to.
figured out that our p hat is 0.427. Maybe it's that one on my screen right there.
That's what I just did. And that's what I just did and came up with the 0.1266.
And then we put that in the applet.
Do you mean 1.266, Joan?
Yeah, negative 1.266.
Okay.
And I put that in the applet and shaded the left side because they want to know less than the 320.
That puts you at 653.
And come up with 0.1028.
So 0.103.
60 points, I'm 60 points ahead of you.
That's correct.
We're better than 300. I was 300 points ahead of you. I was over 300 points ahead of you.
I'm not confident that that's what it is, but
You can't even give us a 95% confident, the 95%.
no.
Oh, goodness.
Okay, Joan, I think you had it because we were kind of coming up with the same thing at
Yeah.
the same time.
So whether it's right or wrong,
Okay. 24. Suppose you're testing HO P equals 0.62 against HA P does not equal 0.62. And you have calculated this test statistic to be Z equals 1.334. The area to the right of Z is 0.091. Which one of the following is the p-value of your hypothesis test?
what?
I think
Yeah.
that one.
You what, Ed?
Isn't that just the second one? I don't think we need anything on this one. I think it's telling us everything. Maybe I'm overthinking it.
Well, your p-value is your probability. So
So if I put it in here,
The game, not two games.
1.344 is it?
1.334.
And it comes to 9, so it's 91. So it's the same thing.
Yeah, because none of this other stuff seems to be making.
Because it says the area to the right of the Z,
Right.
1.334. So they're talking about the area to the right. So if you just shade the right side area
yeah,
with the Z score of 1.334, it comes up with
0.091.
Yep.
I think that's it.
Yep. Good call, Joan.
Yes.
I'm impressed.
Let's make it more complicated than it needs to be.
Yeah.
Okay, suppose you're a dog breeder and you want to use a confidence interval to estimate the true mean fertility levels of purebred Cocker Spaniels. It is known that this distribution of fertility levels of Cocker Spaniels is normal. How many measurements must you have in order to be sure the sampling distribution X bar is normal and is greater than 30? That's what I'm going with.
I think it's that simple.
Any N will do. Love the last one.
Measurements must do in order to show the sample. Yeah.
Because
Man, it's so much information for something so simple.
the last ones had to do with proportions, but this is
Right.
a question about quantities.
Right.
Yeah.
So I think it's that first one.
Okay, so a study is planned to compare the proportion of men who dislike anchovies with the proportion of women who dislike anchovies. The study seeks to determine if the proportions of men and women who dislike anchovies are different. A sample of 41 men was taken, and the p-hat estimate for the true proportion of men who dislike anchovies was determined to be 0.67. A sample of 56 women was also taken, and the p-hat estimate for the true proportion of women who dislike anchovies was determined to be 0.84. Are the requirements satisfied to perform this hypothesis test? So we need to go back to that chart, Ed, since you've got that.
Yeah, I think it's this one here. Requirement for a 2 proportion test.
All answers must be greater than 10.
So let's see, what was the N1? 41. And the portion of the N1 was 0.67.
I need a pill for my.
The sample of 56 women and 0.84.
And they were 8.4. So
Is it the second one?
well, just to show you how this chart works.
Yeah.
And I don't use this Excel spreadsheet as often as I use my hand calculator. So I have to think about this for a second.
Oh, so you've put all these in there.
Yeah.
Ooh.
So this
Chandler,
first.
get Chandler. I'm about ready to die. You didn't plug me in over here.
Oh, we're gonna wait.
Hey, I'm just telling you. She's about to die.
Is this one?
I guess my charger didn't get plugged in.
This one?
Trying to win.
Yeah, come.
Run, Forrest, run.
Thank you. Run, Forrest, run. You guys are cracking me up. Okay. All right. I'm now cooking with gas. Okay. So you
Good.
put all of these in, and one of them is not greater than 10.
Yeah, and like I say, I don't usually use this. I just have it to kind of help me during
Right.
the textbook portion. So this
Right.
first one, this 27.5, is the answer to this first one here. The first
Right.
formula.
Right.
Second formula is 13.5.
Right.
Third formula is 47. And then the fourth formula is the 9.
Right. And they all have to be greater than 10.
Yeah.
So we say no.
I
Because-
think, yeah.
Because in at least one case, it was less than 10.
Yeah.
Fabulous. Love those
Makes
formulas.
Okay.
Okay, so a study was conducted to measure the effectiveness of a diet program that claims to help manage weight. Subjects were randomly selected to participate. Before beginning the program, each participant was given a score based on his or her fitness level. After 6 months of following the diet, each participant received another score. So this is that pre and post, remember? The study wanted to test whether there was a difference between before and after scores. What's the correct alternative?
So again, the difference, so it's the MD does not equal 0.
That's what I think.
The second one.
Yeah. Yep.
Yep, I agree.
It's a matched pair dependent t-test. Second one, okay.
Weight Watchers wanted to predict how much weight a client would lose if they followed a prescribed exercise program in addition to the diet. Volunteers were randomly divided into 2 groups. One group dieted but didn't exercise, and the other group dieted and followed the exercise program. For the exercise group, they used linear regression with percent compliance with the exercise program as the explanatory variable, and pounds lost in 3 months as the response variable. One of the clients was told that his residual was 5.5 pounds. What does this mean? So it kind of gets down to, we're using linear regression and residuals. The residual is 5.5. So what's the sentence you would use to tell him what that means?
I think I remember from Sister Lemon's video that it means that for every 1 whatever, unit.
Yeah.
Every unit on the x-axis, the y-axis will either go up or down by that other one, which in this case is weight.
Just try not to remember.
Well, it's talking about weight loss in every one, either predicted or actual. The first one and the fourth one are talking about predicted weight loss. The two middle ones are talking about actual weight loss, to begin with. And then they end with the other. So the predicted weight loss was 5.5 pounds higher than his actual. The actual weight loss was 5.5 pounds higher than his predicted. His actual weight loss was 5.5 higher than it should have been if he didn't exercise, or his predicted weight loss was 5.5 pounds higher than it would have been if he didn't exercise.
I think it's the second one because the third one has nothing to do with exercise.
Use linear regression with percent compliance with the exercise program as the explanatory variable and pounds lost in 3 months as the response variable. One of the clients was told that his residual was 5.5 pounds. What does that mean?
Well, the residual, I don't know whether he gained or lost.
Well, but they were comparing compliance with the exercise program with the explanatory variable and pounds lost in 3 months. So they were only
As the response variable. And
right.
okay.
They were only keeping track of pounds lost.
Okay. So his residual was 5.5 pounds.
Right. I think it's his actual weight loss was 0.5 pounds higher than it would have been if he didn't exercise.
Hmm.
Because let's think. So they were looking at compliance to exercise and weight loss. Oh, no, that doesn't make sense.
Well, the residual is the difference between the observed value and the predicted value.
I don't think it's the third one because it has to do with
So then it would be his, so the residual is the observed value. What is it? The observed value.
It says the observed value of the dependent variable y and the predicted value.
It's the difference between the two.
Yeah, that's what a residual is.
And this makes it the second one then, because his actual weight loss was 5.5 pounds higher than his predicted weight loss.
No, you can't do that. Cheating.
The residual was what they observed. They observed that he lost 5.5. His residual was 5.5. So that means
so
he observed 5.5
more than the predicted.
more than the predicted weight loss.
Yes, you're right.
Okay, that sounds good, ladies.
Yes.
Does that make sense?
Yes, yes. All right. For the same study in the previous question, the B1 of the regression line was 5 pounds. Interpret this statistic.
Oh, this is what I was just talking about. This is where I think I was thinking.
Okay, go with it. Go with your thoughts.
Third one down, as percent compliance goes up by 1 unit, on average, 5 pounds are lost.
20 points.
So there's it's a
Yes, right.
it's a 5-to-1 rate,
Yes,
5-to-1 slope.
yes, it's the slope. Yes, I
That's
agree.
it.
Yes, yep.
So the third one,
Yes. Okay, when creating a scatter plot, a residuals plot, and a QQ plot, which of the 5 assumptions about linear regression are being checked? So there's the 5 assumptions. Oh, where is my big old chart for that?
I am glad you have a big old chart for that.
Well, Emily, can you grab me those papers on the table right there, please?
I actually have on my screen the
The big old chart.
thing from Sister Lemon's video.
Well, I was going this from the,
Yeah.
so, all right.
So the first one in Sister Lemon's video talks about a linear relationship.
Right.
That would be the 4th one down. The second one talks about a normal error term.
And this is check all that apply.
Yeah.
There's a linear relationship between X and Y. The error term is normally distributed.
And an error
Is there-
term is somewhat synonymous with the word residual. So that would be the second.
Oh, okay, yeah. The variance of the error terms is constant for all values of X. That's the last one, right?
yep.
Yeah.
The X's are fixed and measured without error. That's the first one. The last one, the observations are independent. It's all of them.
Well, the last 2 cannot be checked. They're impossible to check.
Why?
Because we don't have the software to do it. I think, let's see. What does it say in my notes here?
Well,
Right,
because,
It says cannot be checked, and the question is, yes, it's being checked.
Okay, yeah. We have to assume.
Which of the 5 assumptions about linear regression are being checked?
oh, gotcha. By using those 3. Okay, gotcha.
So you can't check the last 2.
Right, okay, yes, I'm following you.
Okay, that was a little bit easier then. So it's number 2, number 4, and number 5.
Hold on. I thought we were checking the first 3.
Oh, maybe ours are in different order.
Okay. Yeah, I better check that. Okay, review with me again. What's the first one you have?
Okay, the residuals are normally distributed.
Okay, that was my second choice.
That was
Okay,
mine too.
there is a linear relationship between X and Y.
That's my 4th choice.
Good. And the variance of the error term, aka residual, is constant for all values of X.
That's my 5th choice.
Good. That's the one where they're all over the place.
Yeah, so my 1st and 3rd are not checked.
Okay.
Me
So
too.
for Nikki's help, the ones that are not checked are the X values are measured without error and the observations are independent. Do not check those,
Yeah, good. That'll help me.
just as a double. All right. We are now going to do the next 12 questions
Man.
with the direct flight cost thing. So get that pulled up.
And the
Direct flight. All right. Pressures of supply and demand act directly on the prices of airline tickets. Here we go. As the seats available in the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline discounts the price. All right. So Allie Henrik, a BYU Idaho student, wanted to predict the price of tickets 14 days before a flight based on the price of tickets listed 90 days before the same flight. I thought we just did this.
Yeah, it's a little bit different.
For her study, she compared the prices of one-way flights from London's Heathrow Airport to various destinations in Europe using Travelocity. She recorded the lowest published fares for 90 nonstop midweek flights 90 days in advance and then found the lowest published price for the same destination, again, 14 days in advance. The prices are given in the file. Notice that for some destinations, flights are not available. Okay, so let's get our files ready. So
Right.
again, this is going to be on the paired sample t-test. Make sure you delete everything that we had in there before so nothing's left. I'm
But they're
talking
looking
out
for the
loud because
sample
I'm,
correlation coefficient.
How many?
say that again?
The first question is asking for the sample correlation coefficient. So that is your linear regression.
The linear regression. Okay. Okay, so in my in my QIP, my explanatory variable, my response variable are which is going to be 90 days and which is going to be 14.
She recorded the lowest published fares for 90 nonstop flights
At 90 days and 14 days.
and then found the lowest published price at the same destination for 14.
Right. So which is my X and which is my Y?
I think the 90 days is,
She wanted to predict the price of tickets 14 days before a flight based on the price of tickets 90 days. So 90 day is what she's comparing the 14 to the 90.
yeah, 90 days of
The
the
90 is your X and your 14 is your Y.
Yeah, that's my
Yeah, I
thing.
think we have to talk that through before, yeah, exactly. Which is exactly what I will do on a test, is talk my way through that to make sure that I'm putting it in the right spots. Okay. Wow, there's a lot. Okay. So like 90 days.
That was stuck with you, Joe. Like, you stuck me.
I knew I did.
Okay, my 90 days are going in here.
112 points. Wow, that's pretty good.
Okay, my 90 days are in there. Now my 14 days.
So 112 is 9, 6, 8, 869.
I'm doing pretty good.
90 days by 14 days. Okay,
Now,
they're in there.
do we have to sort these? We have to sort these?
Not at this point. You
Okay.
you sort them when you take the residuals and move them over to the other,
I want to go away.
right? Because if I look at my scatter plot that it already gives me,
All right, all right.
Right, it's somewhat linear.
yeah, I've got this one outlier clear over here. Does yours look the same? Oh, let's see. Does mine look
Yes.
the same? Yes,
Yep.
mine looks the same. Okay, mine looks the same.
Good.
Okay, so what the heck is the question?
I know. That's what I was going back to. Compute the sample correlation coefficient of the price of tickets. Give your answer accurate to 3 decimals. So it wants the sample correlation coefficient, which is the R, 0.780, correct?
That's what I'm thinking it is, yeah.
0.780. Okay, create a scatter plot using these 2 variables.
Which we did.
Which it's already on our linear regression, right? The scatter plot's there already. Right?
Right.
Okay.
Yeah.
Create a scatter plot using these two variables. Using the scatter plot referring to the correlation code, select the answer best describes the data illustrated. Linear with a fairly strong, it's a positive. It's a positive. It's a fairly strong positive. Yeah, it's going up.
Yeah,
If these are my only choices, it's linear with a fairly strong.
yeah.
Positive. It's going up.
Definitely not negative.
Right, and it's not nonlinear.
Yeah.
Okay, for the next two questions, compute the y-intercept and the slope of the linear regression line to predict the price of tickets. What is the y-intercept? So the y-intercept is 115.640.
Right.
Okay. 115.640. What is the slope? 0.627.
0.627.
Agreed.
Predict the price of tickets listed 14 days before a flight based on the same flight costing $200. 90 days before a flight. Give your answer accurate to one decimal place. So that's where I come up here.
And you put the 200 where the X is?
Yes.
So it's
It's 240.979.
240.979.
Yep.
What did you get?
240.979.
Okay, good. It says give your answer accurate to one decimal place.
Oh.
So 2.240.
241.
Yeah, $241.
Do you do 0.0?
I have to put the 0.0 in there?
That's it. Yeah, that's what I'm wondering.
I would,
Yeah.
because it says give your answer to one decimal place.
For the next three questions, construct a 95 confidence interval for the slope of the regression line obtained when 90 days before flight ticket prices are used to predict the 14 days before flight tickets. So this is just asking for our lower bound and our upper bound.
Yeah,
And our lower bound is, remember she said always use the slope, the bottom one.
yeah, the bottom
So
line.
it's 0.518.
Right.
That's
It's
right.
yeah, you want to make sure
0.518.
you want to make sure you have 95 in your confidence level.
Let me make sure I do. I do. I thought I did before. So yeah, good point. And then
0.518.
and then 0.735.
That's what I have too. Good.
Copy.
518 and
We're almost there, you guys. Oh my gosh. Determine margin of error. I have my MOE on it. It's 0.108.
Good.
Hang on, let me do the count. 18.
all right, hold on, just let me find it on my sheet.
37.
I swear my computer mouse is now acting like someone else has control of my mouse. Like I
Where's-
move it and it's going somewhere else.
Where's the margin of error?
You have to do it yourself. It's not on our form, so we all added it. And on this one, I used the sum is M15 minus L15 divided by 2.
Oh, I'm sorry.
I put it right next to my confidence intervals and called it the MOE.
I concur.
.475.
Negative. So it's the in hand calculation terms, it's the upper bound minus the lower bound
Divided by 2.
divided by 2.
M14 minus L14 divided by 2.
No, M15 minus L15.
Oh, you know what? I have 14 on mine.
Yeah,
Oh,
me too.
maybe, hold on. I wonder what I have. And
No, I think the 0.108 is correct. I think
you're right. It is 14 and 14. I added a line.
Yeah.
Sorry. Sorry for that.
Give you
So
a
I have,
number.
so I have M14 minus L14 divided by 2.
Yes.
Yep.
And my answer is 0.475.
No. You
Okay.
got to do the M15 minus L15 in parentheses, then divide by 2.
Arr!
Yeah. Yeah. Or your order of operations is incorrect.
Oh, shoot.
Gosh, 2 more weeks. Not even.
Well, no, one more week.
Yeah, because it has to be done by Wednesday.
Final is, yeah, it's only open Tuesday and Wednesday. So we're almost done.
Equals. Correct. Yes. Who's correct? I have messed up something somewhere.
Hmm.
I just messed up a formula somewhere.
That's okay. I'll read it to you exactly as it says in the cell, and it might.
I know, but I have to no, because I messed up my confidence interval one.
Oh.
What's your formula in M14?
Oh man, it's
Right, it's 1,000 things, right? All right, so
Close it out. Don't save it and bring it back in.
oh yeah.
Yep, but then I have to go put the stuff back in again.
Right.
Or you could trust Raylene and I. Oh,
Yeah,
but you add your margin of error. No, let's take the time so you can get this.
Yeah. Get your margin of error right. Or just keep going backwards, right? Undo typing.
Yeah, it's too late. I already.
Oh, okay. Well,
So we said 14. The 90 days are in the A column, right?
yes, 90 days of the X, 14 days of the Y.
See, this is what's going to happen to me in the testing.
Yeah. I'll just toss this out. I open a new QIP and a new QDS for every new question.
Oh my God.
And I just start fresh. And then I add colors as I need and notes as I need. Because I don't really like Excel. I'm old enough to where I kind of am a Luddite with my technology.
Okay, so no E. So equals sum. Let's see. This divided by 2. It's not doing it for me. What the heck? Equals.
This one hasn't been opened.
It won't do it for me. So it's the equal sign and the word sum.
Yeah.
And parenthesis.
M14 minus L14, close parentheses.
Yep.
Slash divided by 2.
1.08.
Perfect.
Hey,
There you go. Now save it.
I
So
did.
you have the MOE in there. Okay, great.
Good heavens.
We got through it.
it's enough to make you say a naughty word, isn't it?
Oh, yes, it is.
Yeah.
All right. For the next 4 questions, conduct a hypothesis test. And I stopped even putting my answers on my paper. I wanted to put my answers on my paper too, but
Right.
that one. Really, we are so at the end of the line here, and
I
I'm
know.
holding back.
Okay. For the next 4 questions, conduct a hypothesis test to determine if the slope of the true linear regression line is not equal to 0. We're still talking about the airline tickets?
Yeah.
Okay.
Not necessarily. I think this could be anything.
You reading by 11 points? I'm reading by 11 points.
How you like that?
I love it.
Make you feel good?
Feels good around the inside here.
Do this for about 300 points.
Yeah.
The next 4 questions, conduct a hypothesis test to determine if the slope of the true linear regression line is not equal to 0.
This is gonna be a rule. If you lose it by 300
Okay, I have notes from Sister Lemon on my screen.
Okay, I'm gonna go there.
I do like this.
Linear regression is the
It's beta.
You don't want to play with
The capital.
Okay.
The capital.
well,
Oh wait.
but is it beta 1 or beta not?
Oh,
See what I mean?
yeah.
That was what was messing me up.
Yeah, I kind of want to play with that and give another reason.
Well,
This is fun, yeah.
Oh, there we go.
Beta 1.
yeah.
Beta 1.
Straight from Sister Lemon.
Because we're talking about, okay. If I go back, whoops. Our slope, the y-intercept is B naught. If you look at your t-test for linear regression on your QIP,
Yeah.
it's asking about the slope, and the slope is B1.
Yeah.
So that's why. All righty. So it's, for me, it's the 4th one.
Yes. 4th. Yes.
Okay. What is the value of the test statistic?
Oh yeah. We do go back.
That's 11.510.
Yep.
11.510.
And the p-value is,
I didn't get to go.
how am I supposed to do that?
No, you put that there.
That's a big value.
Yeah. How do I write that out even?
I'll do it. It's this.
Okay.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
Well, we just have to do it to 3 decimals.
2, 4, 6. Yeah. That's
So
it. Right.
So you have it. Where did you put it?
Oh, sorry. There it is.
Oh, so it's 0.000. That's really all we needed to have.
That
Which I
is,
knew it was at 0.000.
that is really.
When it says 19, you put 18 zeros and then a 4.
Yeah.
Okay.
But it's 0.0.
0.000, round to 3 decimal places. What decision do you make based on the p-value and the level of significance, and thus, what do you conclude? Well, the p is low, reject the HO.
No, P is low.
Reject the HO. So it's one of the bottom 2.
And if you reject, there's sufficient evidence.
Right.
Yep.
So it's the 3rd one. Reject the null. There is sufficient evidence to suggest that the slope of the true linear regression line does not equal 0. We conclude that there is a linear relationship between 14-day ticket prices and 90-day ticket prices.
Yep.
Okay. In the United States, I think we're in a new thing here. We're not talking about flights anymore. In the United States, mothers who live in poverty generally have babies with lower birth weight than those who do not. The mean birth weight for babies born in the U.S. to mothers living in poverty is approximately 2,800 grams. The CDC carries out a study to test the effectiveness of a new prenatal care program in reducing the number of low birth weight babies. For the study, 30 mothers, all of whom live in poverty, participate in the program, and birth weight data is recorded. Which hypothesis test would be most appropriate for this study? 30. So they had to have 30 mothers in poverty.
Okay, it's just what test is it, right? So we're
Yes.
talking about calculating birth weights.
So it's quantitative.
So it's quantitative,
Yes.
which means that it's I think it's a one sample Z test because they give you the mean, and if you have the mean, it's a Z. It's a T if you don't have the mean, right?
No, it's whether or not we have the standard deviation.
Oh, right.
So it's definitely quantitative, definitely one group. If we know the standard deviation, it's a Z. If we do not know, it's a T.
It's a T.
Nice, so you got 3.
So one
Right.
sample T.
Yeah, okay, that was pretty easy. All right, second one.
Well, first one for me.
Really?
Mine was the second one. I had one sample Z, then one sample T.
Okay, good. So
So
it's
for Nikki, whatever number it is for you, it's one sample T test.
one sample T test. Got it.
Okay, now 44. Engineers at an oil refinery find out how easily gasoline evaporates by measuring its vapor pressure. As they make gasoline, they need to determine whether its vapor pressure is high enough. Standard deviation, we know it, of the vapor pressure of the gasoline made by the refiner is always 0.03. Which hypothesis test would be most appropriate for this test? So the standard deviation is known.
It's known. Okay, yeah, it's pressure is quantitative, not categorical. So it's quantitative, it's one group. And then, yeah, in this case, you're right, Raylene. We do know the standard deviation because
They tell
they've
us that.
refined a lot
remember-
of
Yeah, go for the clues.
So
So
one
that's a one
sample,
sample Z.
Yes. Which
that's
is
it.
my first one.
One sample Z test.
All right. An attorney wants to know whether the percentage of Walmart employees in Nevada who are over 45 years old is more than 30%. Which procedure would be most appropriate in this situation? Walmart employees who are over 45 years, he's saying it's more than 30. So more than 30% of the employees are over 45.
All right, so this isn't quantitative though.
Correct.
No.
So
It's
it's a
categorical.
a
It looks like-
test of one proportion.
That's where I was going, was a test of one proportion.
Test of one proportion. I agree.
Okay.
46. A marriage counselor conducted a study of couples, categorizing each of the couples as communicative or non-communicative. Among other things, the counselor wanted to see whether the percentage of communicative couples whose marriage ended in separation or divorce was the same as the percentage of non-communicative couples whose marriage ended in separation or divorce. Which hypothesis test would be most appropriate for this study?
So again, this is categorical. So
Yes.
is this a test of two proportions?
I think it's a test of 4, and I'll give you my reasoning. I drew a chart out on my scratch paper earlier this afternoon, and I have 2 columns and 2 rows. We have one group communicators and second group non-communicators. Then another group of people that stay in marriage versus a people that leave marriage. So it sounds like 4.
Okay. So the categories are communicative and non-communicative. Among other things, the council wanted to see whether a percentage of
Okay?
communicative couples whose marriage ended in separation or divorce was the same percentage of non-communicative couples who are ended in separation or divorce. So inside of each communicative and non-communicative is separation and divorce, separation and divorce. That's
Right.
still two groups with two things inside of it.
Right.
13,
That's my thinking.
17. About 10, 15.
Where's our chart?
So, right, I'm looking at like the chi-squared, right?
I was
It has
starting
like,
to look at chi squared too. Where's chi squared? Chi squared.
that's on the categorical hat. So there's columns and there's rows. So there's two rows because you have married, divorced, and non-divorced.
Divorced and separated, right?
Oh, divorced and separated. And then,
Oh, sorry, you don't like me to see it.
yeah, I think it's
You wanna play again?
a sample of two proportions actually, because you have your
Well-
first sample.
Well, and my other thing is they didn't really, they're inside of each of them, where you separated divorce, you get a check mark.
Right,
You know what I mean? Because they both are, you're not really totally married anymore. You know what I mean? Like operating like a married couple.
right. So you
So-
have your
so it's
X1
not,
and your
are you
N1 and your
separated?
X1
It's-
and your N1.
Yeah, it's not, are you separated? Are you divorced? If you're either one of those, you get an X mark.
Yeah, I think it's chi-squared, but I'll go with you for now.
What were you saying, Joan?
I think it's two proportions.
The reason I don't think it's a proportion is because a proportion is like 5 of 10 people stay in marriage, or
Okay, so you're right. Like the proportion is of 50 people, 40 said this.
yeah,
Right.
Because you have your X number, you have your X, which is your statistic, your success. And then you have your number of how many people. So how many successes did you have? So let's,
When they're looking for a percentage, they want to know a percentage that were separated divorce. So if you had 100 people and 10 of them were separated or divorced, that's 10%.
among other things, the counselor wanted to see whether the percentage of communicative couples whose marriages ended in separation or divorce was the same as the percentage of non-communicative couples. So if we're looking at percentages, is it still categorical?
Because you're actually adding them up. It's quantitative.
Right.
Because if you're married or divorced, if you're separated or divorced, that's a number one. The next couple, are you married or divorced? Yes. That's the second couple. Are you married or divorced? Yeah. Are you separated or divorced? That's another one that you count. So you're counting every divorced or separated couple. And so then you say that out of those, there was, you can figure out a percentage. And then same within the non-communicative group. So it's quantitative in that way.
well, yeah, the very first sentence has the word categorizing each of the couple. It has the word categorizing in it.
Yeah. So you've got two groups, and what's the percentage in each group that are, for all intents and purposes, not married anymore, separated or divorced? And so you count how many those are in order to get a percentage. And you're saying, are the percentages the same or different in the communicative and the non-communicative groups? So you're quantifying that. You have to quantify to get a percentage, right?
Yeah. So on my screen is
And I think the categories are throwing us off that we're thinking that's categorical.
well, there's some flow charts on my screen from Sister Lab.
Okay. All right.
Am I counting something?
Yeah. Am I counting something or am I measuring something?
I think I'm counting two groups.
I think I'm counting two groups as well. So that makes it categorical.
Okay. But then it's not 3 or more groups.
Well, it would have to be, yeah, either two group or 3 or more groups. And the reason I think it's 3 or more groups is because we not only have a group of people that are communicators or non-communicators, we also have a group of people that either stay married or do not stay married, which I think is the essence of an ANOVA. I think there's a, you know what? What lesson did we do ANOVAs?
Well, you have your communicative and your non-communicative. And then you have your ended your marriage.
And you're counting bad relationships, let's say, in each one.
Yeah, okay. So on my screen, I have an old from lesson, yeah, whatever.
Right.
An ANOVA test, or a chi-score test, rather. And this particular chi-score test has Republicans, Democrats, Independents, and it has females and males. So,
but they don't care about the married ones. They're not looking at married as opposed to not married. You know what I mean? They're just count. I mean, you end up knowing that, I guess. Yeah.
All right, well, let's talk this through for a second.
Yeah.
Yeah, do.
So we're saying it's categorical, right?
Yeah.
So a test of two proportions. Ed, if you could put that little chart up there, categorical and quantitative.
Oh, yeah. Oh, sorry, this one.
That one, okay. Three or more groups. It's not 3 or more groups, in my opinion. You know what I mean? Like, do you think it's 3 or more groups, Ed?
No,
Where do you think you're getting the groups?
I think I think we have a group of communicators, and number 1, number 2, non-communicators, number 3, people that stay in marriage, number 4, people that do not stay in marriage. But I am totally fine with going with two proportion Z-test. And then we can revisit this if we get this one wrong.
Well, because it says for the chi-squared, it says keyword independent.
Yeah, I actually added that based on
right.
but I think that's what it means.
Right, it's three or more groups. Just asking, where are you leaning, Raylene?
I'm trying, I was actually going and doing some studying, you know, like going back in some notes actually.
Yeah.
And I haven't watched Sister Lemon's videos yet for the.
I haven't either. So. See, I'm what I have highlighted but not checked is I'm still with test of two proportions.
Yeah,
That's where I am.
that's where I am too. Doesn't
Okay, let's go with that. Test of two proportions.
really. It's still,
And then we're on the last one.
I am-
Okay, here we go.
Yes.
A business marketing firm specializes in radio advertising. They hope to show there is a linear relationship between sales and the amount of money a client invests in radio advertising. Which procedure would be most appropriate for addressing this question?
is linear the buzzword?
Yeah, I'm going with linear regression.
Me too.
All right, who's submitting?
Yeah.
I will. I will.
Okay, good.
Because I'm used to when I submit getting only like
Have
70%.
to write 47 questions back down again.
I see a 0 there. I see a couple zeros.
Oh, crap.
Yep, 85%. Got 40 out of 47.
Oh, okay. So which ones
Yeah, that's awful.
did
Yeah,
we
let's-
miss?
Oh, I would be thrilled if I get an 85% on this final exam.
Yeah,
Well,
me too.
I actually agree. Yeah.
Question 4.
Okay,
This is the median will decrease, the median will increase.
right.
It's not
Okay.
possible to determine. So, where do
if
we
it's
think
not,
we
so,
want to go? 'Cause
okay,
what-
so if,
what will happen is one of you guys will change it and then you'll submit and see what you get.
Yeah.
right.
Let's not submit yet, though.
Yeah.
No,
Let's
gosh,
go
no.
through them. So number 4 is for Nikki's safety. Number 4, Nikki, is not the median will decrease.
Hey, by the way, I just got a text message from Nikki. She's meeting with Sister Lemon at 8 o'clock. So she's totally all by herself. She's not going to have a chance to watch this.
Okay.
But anyway, that doesn't matter.
Okay, so if it's not the median will decrease, are we back to the median will increase?
Yeah, let's give that a try.
Okay, so what's the next one we missed?
All right, 1 sec. Because I'm writing it down and I'm checking it off. Oh, wow, I have to, so 4. Okay, so I'm going to just, all right. What's the next one? Oh, wrong. Oh, number 9, which is the tanker trucks are designed to carry huge quantities of gasoline.
Oh,
This one was the one I was concerned about. It changed to 85-40 gallons, and I didn't feel like we put that
yeah.
in there properly.
Yeah. Well,
Because our N changed to 50, and we wanted to see if it was going to be greater than 85-40. So the sample mean was 85-50, but if we change it, the capacity, the N to 50, the probability that it will be greater than 85-40.
so where was that?
You may still have it in there. 85 there. Okay. So you're kind of right there. I don't think that we have to put the mean as 85-40. We just had to show the probability is greater than 85/40. So we have to use the normal probability app, right?
Sounds-
Right.
So to change that, the mu was 85/44. The standard deviation is 12, and we're going to change the mean, or the n, I'm sorry, the n to 50. So given all that, we want to know the probability that the sample mean capacity of the 50 will be greater than 85/40.
All right. So what part of the spreadsheet are you on?
Close to the top.
The Z, find the percentile when Z is unknown, that one?
No. I was on about line 23, I think. Z score for sample means.
And student T calculator?
Yeah.
Okay. So we had 8550.
Oh, so this is the student's T calculate, not the normal probability app?
No, I think it's, if we were dealing with degrees of freedom, it would be students T.
Okay.
The formula is the same.
Okay, got it.
The only difference is they're two different applets, but the formula is the same.
Okay, so we have in there then, so our X bar then is 8550.
Yeah, that sounds right.
Our mean,
The mean is 85/50.
is also 8550.
What we want to find out in the second question is if we change n to 50, what is the probability that that the sample mean capacity of 50 randomly selected tanks will be greater than 85/40? So if we leave it all the same, but we change our sample to be 50, we just want to know the probability that it's going to be greater than 85/40. So the mu, they didn't say the mu changed. So if the mu stays the same, okay, but the sample changes to 50, what is the probability that it's going to show more than 85/40?
But does 8540 go in the X bar then?
I'm kind of leaning towards this is the 65, 95, 97 thing.
Oh.
Like without it saying so much. I could totally be wrong, but that's where I'm leaning.
So if it's 8550, right? And the standard deviation is 12. 8540. So it's less than one standard. Because if you figure 8550 is the middle.
Right.
And the standard deviation is 12. So you go out 12. It's only out by 10. You know what I mean? They want to know 8540 is less than one standard deviation away.
Right.
So what was our answer?
We put 0.987, which is, less than one standard deviation away.
Right.
So the probability is a little bit to the left of the mean and everything to the right, correct?
Because the question is more than 8440?
More than 8540.
Okay. Maybe on my screen, I have the normal probability applet open.
Yeah.
I put in our z-score, which we got correct. And I shaded just the right tail instead of before we had all of this shaded, and that was wrong. But this time we have this shaded.
Well, okay, if you leave this on here, our mean is 8550, right? Which is 0.
Right.
Okay. And so then it says, if I changed my sample from 20 to 50, what's the probability that everything is going to be greater than 8540, which is just a little to the left of 0 and greater to the right?
Right. It doesn't make sense that our z-score is right, but then we don't get that right.
Yeah, I know.
You can't shade, if you shade the whole thing, right? Like shade the middle.
Right.
Then it gives you, isn't that where we got the 0.987?
What is the probability that the sample mean capacity of 50 randomly selected tanks will be greater than 8540 gallons? And that's why I'm like, this isn't going back to our 68, 95, 97, is it?
This is where we got the 98, the 987 here.
Right.
Okay. Well, the left shouldn't be shaded because we want more than the 8440. And then the right should be shaded. But it's still the same thing then.
But I'm saying that it's really from the hump, right, from a little bit left of the hump, not quite to the 1 and over. So I don't know.
But we can't shade it that way.
But is that the 68% plus the 90? You know what I mean? The 68% is the 1 and the 1. You know how we add each of those going over? That's why it makes me wonder if we're supposed to add those. You know, the 34%, the 34%, the 13.5, 2.35. Let me just 34. It's 34 plus 13.5 plus 2.35 plus 0.15. 34 plus 13.5 plus 2.35 plus 0.5 is, I get 84.
84%?
Yeah, but I still feel like I'm on the right path, but not sure.
Right.
Because 12 is our standard deviation and we're at 10. So we're just a little less of that -1. And we want to know what is our probability of a little bit less than that -1 and everything to the right. And between the -1 and the 1 is the 68%. Then between the 1 and the 2 is a 13.5. Between the 2 and, you know what I mean? So that's what I was trying to kind of add up. But it's not exactly right because I'm a little less than the -1.
What are some of the other answers? Oh, or it's just a fill in,
It's
right?
a fill in, yeah.
All right. All right. Well, that one's tough. Then I don't know. I don't know. And I'm.
Should we take a guess and then?
Yeah, we could do the 84%.
Okay. So 0.84. The probability is 0.84.
Yeah, would you do 840?
Does
Yeah.
it say 3? Yeah.
So you're pretty, Raylene, you're pretty sure it's not what I have on my screen. You're pretty sure it's not point.
Let me look at that. Hold on. Let's see. I don't know what to think, because when you go to 8540, that's less than the mean. So you've got to be to the left of the 0. Right?
Right.
But not that much left to the 0.
Yeah.
That's what's messing me up.
Well, let's see, this left tail shaded.
Oh, the question, what is the question? The question is, what's the probability that the sample mean capacity of 50 randomly selected tanks will be greater than 8540? That 50 randomly selected tanks will be greater than 8540.
Well, that sounds an awful lot like that. It sounds an awful lot like our last answer that was wrong.
Yeah, and you know what? I'm not going to kid you. It's 11 o'clock here. I don't care if I get one wrong.
I'm 11. I know it's 11 o'clock for me too.
Got to move on to 10.
Okay. Hey, let's just put something in. Should we go with 0.84? No,
Okay.
it has.
That's
Okay.
fine. So we got 10 wrong.
Yeah.
Which one of the following best describes the notion of the significant level of a hypothesis test? The significance level of a hypothesis test.
Which one are we on? Sorry.
Question 10.
9 is 0.840.
For lack of a better term, yes.
Yeah.
Okay. 10. Which of the following best describe the notion of significance level of a hypothesis test?
So it's not the probability of rejecting HO, whether it's true or not.
Okay, where's our type 1, type 2 error chart?
Oh, I think it's probability of, I'll bring it up. I think I should have looked at this earlier. Let's see.
Type 1, type 2's there. As the probability,
Yeah.
the significance level of a hypothesis test is the probability of a type 1 error.
You see that on my screen?
It's right there.
It's
There
right
we go.
Dadgummit. Okay,
We
got
didn't
it.
even bring that up, and we should have brought the chart up before we eliminated.
Yeah. Yep.
Oh, lesson learned. Okay. All right, what's the next one?
Sorry.
That's okay.
10. Probability of type 1. Because I'm going to have to go back and put all these in again.
Right.
Yeah.
Question 21. The little brother in the career batting average.
Ew.
Oh, this is the one we're like, oh, that's simple.
Yeah. Well, then maybe I think it's probably the second one.
3 times 2.250.
Yeah.
Okay, I'm going with that one.
Okay.
All right, what's the next one?
Sorry, hold on. That's question 21.
Yes.
Yeah.
21 is yes, 40 times 0.250.
30 times 0.250. Somehow I think I'm messed up here. Question 24. We have 0.91 where we just took it right out of the thing.
Oh, we even calculated that. I mean, we sat and calculated it and went, hey, Joan, good eye.
Yeah.
Somehow I got messed up on my numbers here when I'm looking at these questions from before. Shoot. All right. You'll have to walk me through it. Sorry. So suppose you're testing equals, again, and you calculate the test statistic to be Z. The area to the right of Z under the standard normal density curve is 0.09. Which one of the following is the p-value of your hypothesis test?
And I still have my normal probability app with 1.334 with the right tail blue, and my area probability is 0.091. Is p-value probability or not?
The area to the right of Z, 1.334.
So it's asking the p-value of my hypothesis test. My hypothesis test is p equals 0.62 or p does not equal 0.062.
So let's see, is this, and I'm just thinking out loud, let me just do something first.
Oh,
Is it 0.182? Because you have to, is
it's
it a
two-tailed.
two-tailed?
It's two-tailed. It says right in the hypothesis, the alternate is p does not equal 0.062, so that makes it two-tailed.
So it's 0.182.
Yeah. That's it.
Got it. Okay.
So that's 24. I have no idea what I did here, but I'm all messed up on my numbers. 25.
25 we got wrong as well?
Yep.
Oh, man.
The dog breeder, how many measurements must you have in order to be sure the sampling distribution of X is normal?
Where's our charts?
So X bar is our sample population. It's not our number. X bar is our sample population because it's the bar.
It's a sample mean. X bar is a sample mean.
Right. So it's not just the numbers greater than 30, which is what we had.
Yeah.
Edna, yeah, stereo.
It's the
How many
sample
measurements?
mean. How many measurements must you have in order to be sure the sampling distribution of N of the sample mean is normal?
Okay, where's our chart for this?
Okay. I think it's the fourth one down. Because with the chart open,
NP greater than or equal to 10 and N 1 minus P greater than, okay. Yes, I will agree. Yep.
okay. Son of a gun.
So we're saying N greater and N, both of them greater than 10, right?
Yes.
Yes, yes.
This is number
25.
N equal to 1 minus N greater than equal to. Okay. I think that was it. I think we only got 4 wrong.
I thought we got 7 wrong.
Oh, here's another one. Oh, the margin of error for the 95% controversial, number 38.
Number 38.
That's the one, I know, that's the one where we had to do the margin of error.
Oh, holy crap.
What?
Say what?
Yeah. Okay.
I don't
Well, we
know.
got a determine margin of error for, okay, did we not have 95% confidence? We did. I have 95% in there.
Was this our linear one?
Yes. With the 90-day and the 14-day.
Yep,
And we helped you get your MOE back.
yep.
And the MOE is definitely the upper bound minus the lower bound divided by 2. That definitely is it. And we put these confidence interval levels in, right? We got those right. 0.518, 0.735. Did we need to go out further?
Huh.
You know what I mean? Did we need to go?
What does the question
Well, it
say? 'Cause I
wouldn't-
don't have the questions anymore. You know what I mean? Like I don't have all the.
Let's see.
The question was, what is, after we gave the upper bound and the lower bound, which we got correct on 36 and 37, then it asks us for the margin of error for the 95% confidence interval, which we do have. We put the MOE in.
How can this be wrong?
And so did you put in 1.108?
Oh, I put in 1.08.
Okay, that's why. So it is supposed to be 0.108.
0.108.
Yes.
Okay, good.
The decimal was wrong.
Thank you. Yeah, because that was like, you can't have all the information right.
And not get the MOE, yeah.
0.108.
Yeah, so
Sorry.
it's just a typo.
Typo.
Okay.
Story
Is
of
there
my
one?
life.
Yeah. Is there one more, or is that it?
Let me see. That's it.
Okay.
All right, Ed, you going?
Yes. Let me. I will go. Let me just get queued up. Submit quiz. Cross fingers. Whoa. 43 out of 47.
All right, so which 3? Dang
Okay.
it.
Go back to the top.
Okay.
Question number 4.
Holy. So it's not the median will increase or the median will decrease. It must be, it's not possible to determine.
Or will the median stay the same? Because again, if the median was 21, that like I was saying before, if the median was 21.2, well,
And then we're putting another one at 21.
yeah, if the mean was 21 and we were just making the mean 21 again.
You're making the mean even stronger.
Okay. Okay, good. Number 4
Okay.
is the same.
All right, medians stay the same. All right.
And again, I don't know if that's true, but
No, we're down to our last possibilities. Okay. Okay.
Okay, what's the next one?
Question 9.
That 9 is going to take us to the grave.
Okay, you know what? I actually forgot. I made a mistake on this. I forgot to change it. What did you guys come up with?
I got 0.840.
Okay. Okay, then I totally messed up. I should have put in 8. That was my bad. I should put 840 and I didn't.
okay.
Okay.
What's the next one?
Yeah.
Okay. All right, what's the last one?
Number 21.
21.
The stinking.
Oh, you little bugger.
No kidding.
So it's not the first or the second one. It has to be no p hat can only be normal if the sample data are normal, which is true.
Yeah.
Yeah, because 40 times the career batting average doesn't make sense, right?
Okay, So first off, we said that both of them were yes, and we got it wrong. So it's definitely a no.
Definitely a no.
And is it no? I mean, p-hat can only be normal if the SAMPA data are also normal.
Or if,
If you take the no off, the rest of it is a true statement. Correct? Or no?
Mhm.
yeah,
The bottom formula never made sense to me. So if we're going to eliminate the bottom one, we either have to say it makes sense or it doesn't make sense.
Right.
okay. I'm going with number 2 then.
The no p-hat,
No p-hat, yeah.
that's my number 3.
Me too.
Oh,
Okay.
okay, good.
Was that the last one, Ed?
No, number 25 is wrong.
Oh, 25. Well, I thought oh, crap. We even went to the chart and looked for this.
Yeah,
How many measurements must you have in order to be sure the sampling distribution is? So how many measurements?
And the n greater than 30 doesn't work.
Nope.
And the 10 and 10 doesn't work.
nope.
It is known that the distribution of fertility levels of Cocker Spaniels is normal. Oh, so if it's known that the distribution is normal, then it doesn't matter how many numbers you have. So I wonder if it is any n will do.
Okay.
That's
All right.
it.
So it's my turn.
Wait,
Is
wait,
that the last one?
probably, but let me just scroll
Okay.
So we are sure. Okay, give it a shot.
All right.
This is insane.
Oh my gosh. Let's just be up till 1 o'clock in the morning. Okay.
Yeah,
Number 4 is still wrong.
Oh my gosh.
So it is not possible.
okay, 4 is not possible.
So we needed more information.
And 9 is still wrong. It is not 0.840. And I may just say, fine, I'm going to take that one.
Yeah, me too. I'm okay with 9 being wrong.
And 21, the p-hat can only be normal if the sample is wrong. So the bottom one that didn't make sense to us is the right one.
The 40 times the 233.
Yes.
Huh.
Okay.
All right. And then I'm still looking. Everything else is okay. So we're down to 44 out of 47. We know how to fix the other 2. So I say that 0.840 is just, that's one for the team.
Yeah,
Because I'm just not, yeah.
yeah.
Okay. Well,
So now we all know what we need to do, right? To
Yeah.
fix our,
I
holy crap.
can't say that I do because now you have to go back in. You have to answer every question again.
Yeah,
Yeah.
I know. So I got to take the time to write 47 questions down.
Yeah, that's pretty annoying. Okay.
Oh,
All
crap.
right.
I didn't do that. And I know I'm off here somehow.
Okay, so do you want me to review it with you, Joan?
If you
Okay.
would, I
Yeah,
would
okay, here we
appreciate
go. All right, number 2.
Actually, you
And-
know what? I apologize. Let me just go ahead and restart myself. Since you can do this with Joan, I'll just add them all in.
Okay,
Rats. Sorry.
that's okay. I haven't written all mine down, so I'm looking at the end game, you know what I mean?
Yeah.
So I'll
and
have you guys go through your test so you can submit, and then I'll write mine all down and then submit, like when we're not together, I'll read it, whatever. Since I was the last one.
All
Okay.
right. You know what?
So-
I'm going to stop the broadcast